My name is Cadet Michael Zinti, and today I'm going to be teaching you guys how to work down azimuth of a star. Let's go! In order to work down an azimuth of a star, you'll need the nautical almanac and the sight reduction tables, which is also called publication 229, calculator, and pencil and paper. The first step in taking an azimuth of a star is actually going out on the bridge wing and using an azimuth circle to take an azimuth of a star, and you have to know which star you were taking an azimuth of by either a star finder, a publication 249, or if you're a celestial master, you just know where the stars are in the sky. So in this case, I'm taking an azimuth of Spica, and I'm using this data from senior cruise on the California Golden Bear. So this was on July 12th, 2014. When I took this azimuth of Spica, I recorded the exact time that I observed the bearing of the star. So GMT time, it was 11, 10, and 10 seconds, and the bearing of Spica was 237 degrees. And our 2100 position, since we were in ZD minus 10, was latitude 1902.2 minutes north and 145 degrees 43.0 minutes east. Okay, I wrote down the script form for an azimuth of a star, and it goes GHA of Aries plus your minutes and seconds, which is 1010, and that you get a corrected GHA of Aries, and then you're going to add your longitude east, and if we were in a western longitude, you would subtract the longitude, and then the SHA of the star to equal the LHA of the star. You need the date and the GMT time to look into the nautical almanac and find out the GHA. Now, when I did this on my summer cruise, I had a 2014 nautical almanac, which they updated every single year, and this is a 1981 nautical almanac, so I'm just going to show you what numbers you need to look at, but these numbers aren't going to be correct. We come to July 12th, right here. Make sure you look on the Aries side, because on this other page it has the same dates, but it's for the GHA of the sun, and we don't need that. For a star, we're going to use this side of the page. When we come down, and the GMT time here, always do GMT time, we're going to come down to 11, and then get this number right here. So in 1981 it is 9515.2. And in 2014 it is 9516.0, so it's fairly close. And to save a couple page flips, I'm going to stay on the same page and get the SHA of Spica. So right on the same page, you come to the right where it says stars, come all the way down to Spica, and here's the SHA of Spica. It's a little different, 1981. And then right here is the declination, south 1103.8. After I recorded down the GHA and the SHA, I turned to the back of the nautical almanac to increments and corrections, and the GMT time was 11:10:10. So the minutes is 10 and the seconds is 10. And make sure you don't use the sun. We're still on Aries. You come down 10:10, 2 degrees 32.9 minutes. We recorded down the minutes and seconds correction. We have 9516.0. You add that to get a corrected GHA of Aries. And then we added our longitude from up here at this position. Added our SHA. You got the LHA of the star, Spica, 04202.3. And when you add all these up, if it's greater than 360, you just subtract 360 from it. That's how I got 042. Then we're going to come over to this little table, and this is how we're going to do our triple interpolation. And we're going to write the LHA over here, 0.42, and then 02.3 minutes on top. The declination is 1114.2. You don't really need to write the degrees down. So on top I'm just going to write 14.2 minutes. And then the latitude, 1902.2. 02.2 minutes. And to do the triple interpolation, we are going to need the site reduction table, pub 229. And so you open up our LHA 042. So you open up to LHA of 042. And on one side of the page it says latitude same as declination. And on the other side, latitude contrary to declination. The declination is south and the latitude is north. So we're going to use the contrary side of the page. And up here on this top is the degrees of latitude, and down on the side here is the declination. So our degrees of latitude is in 19, come down to 11, and we have 122.5. We're going to take that number and write it across the board where it says base Z. As you see on this next row down, it says next higher. So in the book, we're going to go to the next higher LHA, which was going to be 043. The next higher declination, which is 12. And the next higher latitude, which would be 20. So we come to this base Z, and we're going to go to the next higher latitude, which is 20. And you just come straight across, keeping the same declination, 123.1. So you write that down under lat, 123.1. Then you go to the next higher declination from the base Z, which is 123.5. Go to the declination, 123.5. And then the next higher LHA. So you have to flip the page. LHA 043. Base latitude of 19, come down to declination of 11, 121.7. You're going to write that in this last open column. Okay, after we wrote this row of the next highers, we're going to take the base Z and find the difference between them two. And since this one is smaller than the base Z, it's minus 0.8. This one is bigger than the base Z. It's a difference of 1.0. And then this one is bigger than the base Z of plus 0.6. And then to interpolate this, you're going to take these minutes, so 2.3 divided by 60 times 0.8, and it comes out to 0.0. So there's no correction for there. Then here we're going to take 14.2 divided by 60 times 1, and it equals 0.2, plus 0.2. And then here's 02.2 divided by 60 times 0.6, it comes out to 0.0 again. And then you add or subtract these and get a number, and since both of these are 0, this is 0.2, and we're adding it from the base Z, and we get 122.7. And up here in the book, it says that we're in a northern latitude, and if our LHA is less than 180, it's 360 minus Z to get the ZN. So we're going to take this number we got, the corrected number, 360 minus that, because this is the Z, and we get 237.3 degrees. This is the true bearing. So we're going to take our gyro bearing, because we took the bearing, the observed bearing by gyro, of 237, the air, and then the true bearing is 237.3 degrees. And gyro plus east, the air east, equals true. So the air is 0.3 degrees east. And if you were trying to find the deviation, you're going to take what your gyro heading is at this time that you took the bearing. So it was 343. We're going to add that gyro error of 0.3 to get true, which is 343.3. And then the variation for the area is 0.3 degrees east as well. So when we add that, or subtract it, because this is true virgins make dual companions, at weddings add west going this way. So we're going to subtract that, and the magnetic heading is going to be 343. And the compass at this heading was 347. So the deviation is going to be 4 degrees west. So this is how you do a star azimuth to find the gyro error and the deviation.